Welcome to The Explainer. So glad you're here, because today we're going to completely change how you look at something you probably stare at every single day. Seriously, I'm talking about the fuel gauge on your dashboard. It seems so incredibly simple, right? Just a little needle or, a digital bar telling you when it's time to pull over for gas. We've all tapped that glass in frustration, wondering if we actually have enough miles left to get home. But right behind that dashboard display, there's this dynamic, high-tech marvel that is literally driving a massive global industry. We're going to reframe that supposedly simple component and uncover the intense engineering and, honestly, staggering economics operating right under our noses.
Just take a look at this number, $6.92 billion. No way, right? But that is the projected value of the automotive fuel level sensor market by the year 2034. To really put that into perspective, back in 2025, this market sat at $3.45 billion. That means we're looking at a super robust compound annual growth rate, or CAGR, of 7.5% over the next decade. What seems like a basic dashboard dial is quietly doubling in size.
Okay, let's dive into this. Here's our roadmap for today. First, the hidden billion-dollar sensor. Second, what drives the market. Third, the slosh effect. Fourth, next-gen sensor tech. Fifth, the global landscape. And finally, the connected road ahead. So Section 1, what drives the market? Accelerating sensor demand.
Well, there are three main engines of growth pushing this quiet market forward. First up, we've got rising global vehicle production, especially over in emerging economies. It's simple math, really. More cars mean more sensors. But the second point, that is absolutely crucial: stringent fuel efficiency and emission regulations. Governments around the world are laying down strict climate policies to cut emissions and improve fuel economy. And to hit those green targets, your car's computer can't just guess how much fuel is left. It needs exact data to optimize engine performance and cut down on waste. And finally, the surging adoption of connected and smart vehicles is turning the humble fuel sensor into a critical data node.
Moving on to Section 2, the slosh effect, the physics of moving liquids.
Now, what's really interesting about this is the massive physical roadblock engineers have to overcome. Imagine trying to precisely measure a puddle of water while you're aggressively shaking the container. That is what we call fuel sloshing. It's the unpredictable movement of liquid inside a moving vehicle's tank. When you combine that sloshing with temperature variations and incredibly complex, oddly shaped modern fuel tanks, you get a multi-billion-dollar engineering hurdle. If the sensor can't read through the slosh, the vehicle gets inaccurate data. And that means reduced reliability, which is a massive headache, especially for commercial vehicles driving over uneven terrain.
For decades, the auto industry solved this with traditional float-based systems. Basically a mechanical float on an arm that just bobs up and down on the fuel. But in today's dynamic driving conditions, these mechanical floats provide really inconsistent readings and are super susceptible to physical wear and tear. Sure, they're still used in entry-level or cost-sensitive cars, but modern vehicles require advanced sensor technologies. Now, these new digital sensors definitely involve higher costs and require precise calibration, but they're absolutely essential for the accuracy today's drivers and systems demand.
Which brings us to Section 3, next-gen sensor tech, beyond the mechanical float.
So exactly how is the industry solving these physics constraints? Well, as of 2024, capacitive sensors heavily dominate the space, holding over 44.2% of the market. Why? Because they offer incredibly high accuracy and durability. Capacitive sensors can deliver precise measurements across all sorts of varying fuel types and different tank configurations. And more importantly, they do this without succumbing to the wear and tear of mechanical moving parts. They are literally built for modern reliability.
But you've definitely got to keep your eyes on ultrasonic sensors. While they might not have the largest share just yet, they are growing at an explosive 8.2% CAGR. Ultrasonic sensors are completely non-contact. They actually use sound waves to measure the fuel level, which means they eliminate mechanical degradation completely. Since they never physically touch the liquid, they excel in harsh operating environments where traditional components would just quickly fall apart.
When we look at where these sensors are actually going, passenger cars hold the volume lead, with a 61.5% dominant share, mostly just due to sheer production volumes. And naturally, the OEM segment, original equipment manufacturers, holds 58.3% of the sales channel because these sensors are integrated directly into new vehicles right on the assembly line. But the fastest growth area, that's actually happening in commercial vehicles at a 7.9% CAGR. This is driven by fleet managers who desperately need exact fuel monitoring to keep their costs in check. Similarly, the aftermarket segment is surging at a 7.8% CAGR. As global vehicle fleets age, they inevitably require sophisticated sensor upgrades and replacements.
All right, Section 4, the global landscape. dominating the sensor race.
Zooming out a bit, it's really no surprise that North America currently has a massive lead here, capturing 36.9% of the global market share in 2025. This is driven primarily by the U.S. market, which alone was valued at $1.12 billion in 2025. The U.S. benefits from a really well-established automotive manufacturing ecosystem and, of course, widespread early adoption of advanced automotive electronics and telematics. Following right behind North America, we see Europe holding 26.8% and the Asia-Pacific region at 24.7%. And this brilliantly illustrates how distinct regional needs shape global engineering. Over in Europe, Germany leads the pack, driven by its world-renowned premium vehicle market and incredibly strict emission standards. Meanwhile, in the Asia-Pacific region, China is pushing the market forward due to rapid urbanization. In fact, Asia-Pacific is the fastest-growing region globally, expected to surge at an 8.6% CAGR. Looking at the Middle East and Africa, Saudi Arabia is a key player, specifically because their vast geography demands highly accurate sensors for long-distance commercial fleet tracking. And in Latin America, Brazil dominates the regional market, fueled heavily by expanding aftermarket services for its large, aging vehicle population.
Down to our final section, Section 5, the connected road ahead, sensors in the age of IoT.
As the Redline Pulse report points out, we're witnessing a total transformation. The shift towards smart, connected fleets changes the fuel sensor from a simple analog gauge into a critical real-time data node. It's no longer just about knowing when to fill up, right? It's about feeding predictive maintenance algorithms and empowering advanced fleet management systems so that vehicles can operate at absolute peak digital efficiency.
And because of this massive digital shift, the competitive landscape is really heating up. Industry giants like Continental AG, Denso Corporation, Delphi Technologies, and TE Connectivity are all racing to innovate. Bosch, in particular, is considered a major leading player here. They recently introduced a whole new generation of high-precision fuel-level sensors designed specifically to meet these intense modern digital demands and improve durability. The race is totally on to create the smartest, most resilient sensor possible.
Which leaves us with this final thought. We've seen how a basic gauge, one literally just designed to prevent you from running out of gas, has evolved into a nearly $7 billion network of advanced capacitive and ultrasonic electronics. So, as our vehicles become fully digitized networks, what other simple components are hiding billion-dollar transformations? I highly encourage you to look a little closer at the hidden gears powering our modern world, because the real innovation is often happening right in front of us. Thank you so much for joining me on this explainer, and keep questioning what you see every day.